Welcome to the Australian Water Schools webinar for today, lunchtime webinar, Next Generation Irrigation Management. Well, it's probably not lunchtime where you are today. There's 25 countries involved and over 100 people, presented by Ivor Gaylard from SWAN Systems. My name's Trevor Pillar. I'm the National Partnerships Manager at iSwarm, and we're delighted to have you with us today. Just a couple of logistics before we get underway. If you want to get involved in the discussion today, raise your hand. We'll see that hand raised, or write in the Q&A icons at the bottom of your screen, you'll see. In fact, could we just try it out? If you could just click on the raised hand icon right now, I'll see your hands. Thank you, Dharma, thank you. Yep, I see that, Melinda. Yep, oh, everybody's got their hands up. That's great. Tim, yep, beautiful. I see all those hands. Wonderful, thank you. Yep, excellent. You can put them all down again, that's good. And that's how we'll get some discussion happening here today. That'll be terrific. Just one thing before we get underway, I'd like to let you know about upcoming training in the Australian Water School. There's quite a few webinars coming up, as you can see there. I won't go through them each one, but there's going to be some great times ahead for water management webinars and face-to-face courses. The agenda for today is 25 minutes presentation by Ivor Gaylard, and then open to you for 25 minutes. Free for all discussion, well, mostly free for all. We're going to be recording this today, so have to keep it above board and good. And that recording will be available after the webinar to you and your colleagues. And there'll be a feedback form we'd love you to fill in as we finish today. You'll get a feedback form that's fed to you. Now, today's attendees, you can see from are all over the place. That's really good. USA, Europe, Asia, Africa, and all around Australia. We're so glad to have you on board. Thank you for joining today. Right, let's get right into it now. Ivor Gaylard, you can see on the screen there, Director of SWAN Systems. SWAN is Scheduling Water and Nutrients. He's an experienced ag scientist. I won't read the whole lot, but these guys, Ivor and his colleague Tim Hyde, both gentlemen and their colleagues have been developing this sophisticated cloud-based practical management tool. The thing that got me a month ago when I saw it was that it was user-friendly. I mean, just about anybody can operate it. And it's about producing food. The next 35 years, they say we need to produce as much food as we've ever produced in the past, the entire human race. That's a big call. I think I've got the facts right, but it's going to be a lot anyway. And with systems such as this one, we're going to hear about today, and there's a good chance we could get near it. So let's get underway. I do encourage you to write your questions or comments in the Q&A part of your, you see the icon at the bottom of the Q&A. There's a chat screen, but if you don't use chat screen for asking questions, we get them lost among all the logistics of the webinar, but definitely do. I can see Syed Khan writing questions in on the chat screen now. That's good. On the Q&A screen, that's really good. We look forward to what you have to say to us today, Ivor, and we'll be delighted to have this discussion. I've been looking forward to it for some time. Over to you.
Thanks very much, Trevor, and thanks to iSwarm for this opportunity for us to share SWAN with you all today, and we appreciate you all joining us. I'd like to introduce you to SWAN. It's, as Trevor mentioned, it's an acronym for Scheduling Water and Nutrients. So who are we? The SWAN team is based in Western Australia, and it's a group of farmers, irrigators, agronomists, scientists, and computer programmers. SWAN started with a challenge several years ago, which was to use mine dewatering to grow good quality food crops without affecting the neighbouring sensitive environment. In order to meet all our clients' objectives, we needed to schedule irrigation up to a week into the future to ensure crop water demand was matched with their water supply program. A large amount of data was being gathered from sensors on site, and to make sense of this data and turn it into meaningful management decisions, we built a computer-based model that provided daily decision support for operational staff, a range of reports to suit the client. It uses accurate site-specific 7-day weather forecasting from the Australian Bureau of Meteorology. And the model was designed to constantly look into the future to optimize water application. Having fine-tuned our model on a number of different commercial scale irrigation operations, we've now spent the last 12 months working with an award-winning professional software development company called NGIS to turn it into a web-based platform and make it available to a much wider audience, basically anybody who's irrigating. Our appraisals of historical data, looking through data of various different operations, has shown that people tend to over-irrigate by around 20%. You might have noticed people with sprinklers on during the rain, which is something we often see. The art of SWAN is in its ability to look forward into in the short term for day-to-day scheduling, so we avoid irrigating when there's rain coming up, and in the longer term for seasonal water budgeting. So what's the logic that we've used behind SWAN? It's providing plants with the right amount of water and nutrients at the right time satisfies the bulk of their regular management requirements. This optimizes input costs and desired outputs while minimizing environmental impacts. Such a management regime is the most economically viable approach, whether the goal is crop yield or healthy parks and gardens. SWAN is a management, monitoring and reporting system designed to realize these goals as accurately and efficiently as possible at any scale, including large and complex operations. So what is SWAN? Briefly, it's a decision support tool. It's a subscription-based service. It's web-based, and it's not hardware. We use hardware, various different hardware. We use hardware that you've already got. SWAN is not hardware itself. And what are the benefits? It's designed to optimize resource use and increase yields, protect the environment, simplify irrigation management and planning, and facilitate reporting and compliance. So let's get into the actual system itself, the platform. How does SWAN work? We've got a dashboard as you come in, and here you can see in this example, we've got 19 different sites. We've got a health point on one site. We've got a bit of a health summary. I'll talk about that later. We've got various key things that we're interested in: water use, projected soil moisture balance, fertilizer use compared to budget. In this example, we're a bit behind. We've got a weather forecast over the next 7 days. We've got a map with our different sites on. And at the bottom, we've got a scorecard for each site. It just gives us a snapshot of what's coming up in the next 7 days. But once we've set up all the fields and parks in your operation, we configure them with all the various parameters involved in the complex relationship between plants, soil, and the environment, as well as your target parameters. So in this slide here, we're looking at soil settings, but we have got settings for crop, for water, nutrients, and the weather as well. These settings can be varied from time to time as things change. For example, as your crop grows, the root depth increases. SWAN and our partners can assist with this exercise if need be. It's quite important. In fact, it's very important to try and get your parameters as well configured as you can, because the quality of the system outputs is directly related to the quality of input data. Just a little demonstration of configuring some of the soil parameters here: drainage coefficient, changing our root depth, just a taste of what's going on there. Okay, so the sensors. This slide shows some of the many sensors involved in one of the sites that we've set up recently. Not all of these are involved in the site itself, but it's showing what's around. We've got weather stations, we've got soil moisture probes, we've got flow meters. So this is a diagrammatic representation of how they relate to each other. So we set up data feeds for the on-site sensors. We work with, as I mentioned before, a number of different hardware models. So in many cases, you won't need to replace your existing equipment. You might have equipment that you've set up already. We don't actually supply equipment ourselves. We combine weather data from multiple sources to try and get the most accurate weather for each site. So we could use your local rain gauge on site and weather data from various different weather stations in the nearby region. We use the Bureau of Meteorology for forecast data in Australia, and we have various other data sources for outside of Australia. SWAN takes all of this data and it models the soil moisture balance, which you can see on this graph here. Our target band is the green area, and we're trying to maintain our soil moisture balance within that target. Soil moisture probe data is graphed alongside this. That's there, and that allows you to calibrate the model parameters for that site. The probe data, the calculated soil moisture balance, and what you see with your own eyes when you go on site should all be telling the same story. This just demonstrates us calibrating the probe data and comparing the curves of our calculated balance with the probe data. They should be telling the same story. Factoring in forecast weather and planned irrigation, SWAN then extends the calculated soil moisture balance a week into the future, allowing you to adjust your schedule to maintain optimum soil moisture. In this example, we're actually a bit below par. We're below our green target band, and I'll just play a snapshot of us scheduling. So we've put in an irrigation, another one. Too much, dropped it a bit. So as you can see, the soil moisture balance was might have been a bit fast there, but basically this calculated balance is changing as we put in forecast irrigations. So seasonal budgeting, we use several years of historical data as a guide. So we have that in the background. We can load your own historical data if you've got it. Otherwise, we use some of the publicly available data for that for your area. But you could also use your own latest forecast for your area. So you might have a 6-month seasonal outlook and use that information for planning the next season. And our system will enable you to quickly and accurately allocate water across multiple sites and vary the distribution over months based on crop demand. It's just a bit of an example here. So we're choosing our months. Which months are we going to irrigate? Not all of them, so up to April in this case. Okay, it's gone. But basically, within 10 minutes or half an hour, you can schedule your seasonal water budget over multiple sites. Reporting, we've got a range of reports which can be run for specified time periods, or you can extract raw data for most of the variables in the system, and you can export these as PDFs or as CSV files if you want to feed that data into another report or analyze it on a spreadsheet. So here we have a runtime report, so you can print this out so that you can go and program your controller, set your irrigation. This is a soil moisture status report for 2 different sites, so it's a 6-month report. So over the last 6 months, this site had 57% of the time it was too dry, whereas the other site, most of the time it was too wet. Budget to actual water, how are you tracking? In this case, we're well below our budget, so that's probably good, may or may not be good. Or you can choose a set of data to extract for a date range, as I mentioned. Irrigation is only half the story. For optimum growth, crops need nutrients as well as water. In our experience with cropping, if you get both the water and nutrition right, you're 90% of the way there. In addition, you'll be minimizing your impact on the environment. There are many examples around the globe of how poor management of these resources has led to environmental degradation. In Australia, the Great Barrier Reef and Murray-Darling Basin have received a lot of attention for this reason. Which leads us to another feature of SWAN, which is combining irrigation with nutrient management. SWAN maintains a comprehensive database of fertilizers, and from this you can build your own database. You can add your own fertilizers, and for those of you who are fertigating or adding your fertilizer through the irrigation, you can create your own tank mixes within SWAN. There's also a database for storing laboratory test results for your water supply. Adding water test results allows SWAN to factor nutrients available in the water into your program. This could save on fertilizers and help avoid applying toxic levels of certain nutrients. This is particularly important when you're using recycled water. Provided required analytes have been tested for, SWAN will calculate useful indices such as the sodium adsorption ratio, which provides guidance on whether that water is suitable for irrigation or not. It will also quantify contaminant loading based on irrigation volumes, and where you have water coming from multiple different sources, it'll enable you to work out a combination that is suitable for irrigation. You can preload nutrient uptake curves for crops into SWAN, which allows you to plan the timing. It'll help you plan the timing of your fertilizer applications based on crop phenological stages. SWAN provides some generic uptake curves which you can use as a guide, but over time, the idea is that you build up your own library of these based on your local experience. You'll need to enter the target quantities of each nutrient, which will depend on multiple factors, such as the crop, the variety, yield targets, and soil analysis, to name a few. Based on these targets, SWAN will then assist in working out a fertilizer program after factoring in nutrients in the background water. It's just an example here. So we're putting in our targets and then choosing what fertilizers we're going to use and putting in the quantities, and we'd carry on that exercise until we met the targets that we were aiming for. And you can apply, you can put your actual fertilizer applications in as well.
Sorry, we're just having trouble seeing your video. It's going blank on the screen. Is there something we could do with your video, sharing the video screen that would make it come live? It was working before we began the webinar, of course, but it's just not coming out for others. Well, we can see your whole PowerPoint, but just can't see the video bit of your PowerPoint.
Okay.
Something else
right,
you could do.
I've run the last one, but
okay, don't worry. We'll have a think about it in a minute.
Okay,
that's okay. That's okay. I'll keep pressing on. We'll if we can think of something to solve that later on during the Q&A time, we'll do it. No worries.
Fine. Thanks, Trevor.
Thank you. No worries. Sorry, everybody.
Okay, so as you go along, you can apply your actual fertilizers. And you can record these. So in this example here, it's showing for this particular week. Now, registering your applied fertilizers could be as simple as just clicking a button and saying, yes, what we planned was what was applied. Or you can say, no, we used something else, add a different fertilizer and put a quantity or put a different quantity of one of the planned ones. And SWAN will report on planned and actual fertilizer application on a nutrient basis for any of the analytes that you're interested in. The third major component of SWAN is what we call the health index. We analyze satellite imagery to measure the health of the crop and track whether it's within target levels that you can set. This example is based on an index called NDVI, which is basically a measure of greenness. And in here we're showing the changing pattern of crop growth and harvesting of an agricultural center pivot over several months. So health index will alert you if the crop is not where you want it to be. So in this case, we're over our target. At this point, we're under our target. And that'll allow you to investigate further. It could be a water problem, could be a nutrient problem, disease issue, or something else. You might need to pay that site a visit. And over time, it'll give you feedback on how your site has performed. We're well aware there's people from a wide area around the globe attending today, which is great. For many reasons, we'd like to see SWAN adopted on a global scale, as well as helping manage individual operations better. Through widespread use of SWAN, you'd be protecting the environment. We live in a challenging environment, and poor management of water and nutrients can lead to contamination of the soil, nutrient leaching into sensitive waterways, and wastage of precious water and fertilizer resources. By using SWAN, we can achieve our production goals and maintain our parks and gardens in a sustainable way. I started this talk with an acronym, and I'll finish with a metaphor. A swan may be graceful on the water, but beneath the surface there's a lot of paddling going on. Likewise, our SWAN takes care of a lot of the hard work behind the scenes. Thanks very much, everybody, for your time, and please contact us if you'd like to see how SWAN could work for you.
That's outstanding, Ivor. Thanks very much for your time and effort in this, and we've been much understanding, much higher understanding of where SWAN's been going with all this, and it's terrific to see. Plenty of presenters, plenty of attendees with us at the moment from all around the globe, and lots of questions. So let's get stuck into this. The icon raise your hands is still all good. If you want to ask a question on screen, just hit that raise your hand button, and we'll make sure that happens. Otherwise, we'll get going with these questions. First of all, from Dr. Priyakant in Armidale, New South Wales, University of New England. He's got two questions. In a limited water region, what could be the trigger point to irrigate with limited water supply, so as not to irrigate too early or too late? He's got two questions, and that's the first one. When you've got a limited water region, what could be the trigger?
Okay, so we basically configure SWAN with your targets, and we start off with a water budget. So you try and stretch that water as far as you can go, or make sure you've got enough water for that crop before the season, or tailor the crop area or crop type for the water available. But then as you go on a weekly or daily basis, you're constantly looking ahead and trying at using your calculated soil moisture balance, planning to apply just enough to meet that crop's demand and factor in, take full advantage of any rainfall that's around, and no more than enough.
Dr. Priyakant's second question goes, can water stress be determined by remote sensing techniques? If yes, then how? And some details, but I would ask you to we're going to have to keep, short, brief answers, and we'll maybe think about another webinar after this one, but let's keep moving it.
Yeah, okay, so yeah, look, we're very impressed with the work that's going on in remote sensing. I know there's a lot of very useful work going on with that. With SWAN, our philosophy has been to say, well, set your targets, which could be determined by a number of factors, and we will alert you if you're inside or outside of those targets. So it's more of a management feedback exercise.
Yep, sorry. cut in.
That's
Yeah.
fine. Yeah.
Yeah. Sorry, I'm probably going a bit quicker than we can possibly get to, but with short time frames. Yeah, that's all right. Andreas Jaramillo is from where is he from? Sugar Research Australia, and he's asked, what crop model are you using? What crop model is being used?
We set the parameters based on the crop, so we've got a number of different parameters we can set, and we've taken every variable into account. So we'll use a model that is specific for a specific crop.
Dr. Saeed Hamid is from Pakistan. He says, hi, thanks again. Just wondering when the water pricing system was introduced roughly, and what was the reason and reaction from stakeholders, especially the farmers?
That's a very region-specific thing. I'm not sure if I can give an accurate answer to that. It's come in at different stages for different people. So yeah, it's
a wider question.
Not sure if I can really do that justice.
Yeah, no, that's all right. That's great, Ivor. It is a wider question and a big question. We've got a Mark Dale ready to come on screen, have a chat with us. Ivor, can we get that rolling now? Are you there, Mark?
Yep.
Oh, good. I can't see your face, but I can certainly hear your voice. Fire away. That's good.
Righto. I last dealt with owner-managers of vineyards, and presumably SWAN is there for a price, but these guys wouldn't use the whole gamut of your monitoring systems. Does it come at a graduated system, or you pay one price and you get the lot?
We are looking at pricing it for different components. So that's something we are, yes, we are looking at that. And we're happy to talk more detail on that if you want to get hold of us.
Yeah.
Okay, thanks.
Yeah, thanks a lot, Mark. Appreciate your question. Peter Hayes has been around for a long time, and most people would know Peter. Good to have you with us, Peter. He asked, you make note of the accounting for root development over the season. Can you take account of in-field variability? If so, how?
We can, if there's clearly defined areas, we could set your field up as separate management units. And so we'd manage each different area separately. Otherwise, the way we work is to average it for management purposes. But on individual locations, you can drill down to more detail.
Sounds good. Yep. And Andreas Jaramillo again from Air. Has SWAN been used in the sugarcane industry anywhere?
Not yet. We're really just finishing building the commercial model, and we have got some interest from people in the sugar industry, so we're hoping soon to have it tried out there.
Yep. Will Lemmer says, do you have table grape or stone fruit producers using the SWAN software?
Yes, we do. Yep. We have table grape. Yep.
That's great. Will is from Spain. That's a long way away. Wow. Can the satellite, Andreas Jaramillo once again, can the satellite imagery be used for irrigation scheduling in SWAN?
We use it as a guide. We don't directly input the data into our model, but we more use it as a guide to see whether we're on track or not.
Yep. Dr. Syed from Pakistan, can we use water from mining for irrigation in arid areas, and can we control pests with SWAN?
The first answer is it depends on the quality of that water. If the water is of a suitable quality, then yes, definitely. And as far as pests go, no, we're not involved in pest management, but we believe that by getting your water and nutrition right, you can minimize plants' susceptibility to pest attack.
Yep, no, that sounds good. Rob Brydon from Water West in Perth is on the line, and he'd just like to have a chat with you. Are you there, Rob? He's the director of Water West in Perth. Yep, all coming loud and clear. Come on board. Yep.
Yeah, just a question for Ivor. Thank you for your presentation today. Just wanted to see...
Your video's not working. unless it's. I can hear you quite clearly. I can hear you quite clearly, Rob, but just the video's not happening. That's
Let's
okay.
continue with that.
Sure.
Ivor, do you actually have examples with respect to your nutrient management system of integrating actual recycled water schemes at this stage?
Yes, we have worked with actual recycled water schemes, so we can go into more detail with you on that.
Yep. Okay. Another. That's good, Rob. Well, let's move on. Professor Wayne Meyer has a comment question. The value of DSS is highly dependent on timely input of field data. What are the minimum inputs needed to validate the model estimates and know how much water is actually applied and how crop canopy and hence water demand is developing? It's a fairly full question.
Okay, so what we have based SWAN on, as far as possible, we like to get actual flow meter readings. So that's where the sensors and telemetry comes in. And we like to have soil moisture probes there. Although the soil moisture probe data is not fed directly into our model, we like to have it there as a cross-check so that we can see whether our model is on the right track or not. We can estimate volumes based on on controller information, but really for SWAN to work properly, actual readings or measurements of water applied is the best way to go.
Yep, that sounds great. Yeah, thanks a lot, Ivor. We're getting near the end of the current bunch of questions, but can satellite imagery be used for irrigation scheduling in SWAN?
It's used as a guide. It's really an indication of whether that crop is performing well or not. So it's not always irrigation that causes NDVI or other indices to be outside of where you want them to be. Sometimes it's other things as well.
Yep. Yep. That sounds good.
Yeah, it's a guide.
Yep. No problem at all. Well, I think, there's a couple more questions here, smaller ones, but Dharma Hagar has asked, how many soil moisture probes would you need for a given area? There's a good one.
We like to have at least, if possible, at least one soil moisture probe per site. But if there's a lot of variability in the soil, as one of the earlier questions pointed out, it's good to have more than one. So that's one of the problems with probes or one of the drawbacks is that they're very point specific. So if you have got variability in your field, then you need to have more probes to take account of that.
Yep. Well, let's just these last two from Andres Jaramillo. It says that has SWAN been used in sugarcane anywhere, and how is the payment calculated per hectare, per user, per year, and some examples? It's a bit more of a commercial question. You don't need to go into the whole, but
sure. We're really just coming hot off the press with the commercial version of SWAN. So no, we haven't used it ourselves with sugarcane yet. We're hoping to soon. As far as pricing goes, we structure our pricing with the aim of the benefits being many times more than the cost of the software.
Yeah, that makes a lot of sense. That makes a lot of sense. A lot of people, I imagine. It's about outcomes, isn't it? I think we're just about there. Look, I really appreciate your time today, everyone, and particularly yours, Ivor, and your close colleague, Tim Hyde, who's been working with you, of course, on this, and both directors at SWAN and founders. We really appreciate your time and effort on everything that's gone on today. We're out of time, we're out of questions, and there'll be a recording of this, of course, but when you log off, there'll be a feedback form comes up, just some tick boxes, and we'd really appreciate your feedback on that. We'll send you the link, the email link, and we will also send you the PowerPoints and videos of today's webinar. There's more free webinars coming up. You can see down there, Managed Aquifer Recharge, Community Wastewater Reuse with Howard Fattlefield and Water Research Australia further down the track. Stay tuned. We'll send you out some reminders of all these things coming up, but really appreciate you all being on board today. Have a great day. Thank you again. Bye.
Thanks. Goodbye, everybody.